what I'd really like to show you is something called differentiation. You know that there are the operations of plus, addition, minus, subtraction, multiplication, division. Well, differentiation is another operation which you talk about later on. It's quite interesting. I'll show you a couple of examples. Say you have y equals x squared. That means that when we differentiate y with respect to x, we write this dy by dx, and that equals 2x. What we do, we take the 2 and we put it down here and multiply by the 2 instead of having it up here, and the squared goes to 1, which we don't normally write. Another example would be y equals, say, 4x cubed, and in that case dy by dx would equal 12x squared. And as we reduce this by 1 and write squared, and this operation is very important in physics. But you're not ready for this, so that's not what I'm going to talk about. I just wanted you to have a bit of a look. What I am going to talk about is this again. And the reason I want to talk about it is that, well, it's the kind of thing I would have trouble in visualizing. I don't, although I've proved this, that this is true, it's difficult for it to have meaning to me, and so I think you need a picture of what is actually happening, and I think it's helpful to write it more like this: equals, well, yeah, equals plus 1. And the way I think of it is, I think of this as being a number. But this, not as a number, but an operation. So I would think of it like this: minus 1. No, that's not minus 1, is it? How stupid. Minus 1 I'll put it in a bracket, you see, and there's the operator acting on minus 1, the number, and that this goes to, goes to equals plus 1. So this is an operation and this is a number. So there's a sort of multiplication in here, and what the multiplication is going to be multiplied by. Perhaps an easier example to think of is, say, 2 plus acting on, say, 4. would map to 6. So if, say, instead I want to write the operation of 2 plus acting on x, in other words 2 added to every number, 2 acting on all the numbers, I could think of it as I draw all the numbers along here. There's 0. 1, 2, 3, 4, 5, and then the negative numbers along here. -1, -2, -3, -4, -5. So if all these numbers are x, all the possible x's, and then for each x we're going to add 2 to them. It's like saying I want to move every number 2 up. To a new line, which would be I don't think that's difficult. To a new position, all the numbers move up, and they all move up by 2. So the whole line moves. And so for this, let's think of another example first before say we have 2 times all the numbers. So that would mean we have a line, here they all are, 0, 1, 2, 3, etc. -1, -2, -3, -4. For each x here, well, 2 times 0, that means 0 stays where it is. 1 would move to 2. 2 shifts to 4. 3 would shift, so it's all stretching, you see. And these negative ones, -1 would shift to 2, -2 would shift to -4, -3 would shift down to -6, and so it's stretching and stretching. So the whole thing's stretching like this. So talking about this, thinking about what this means, if you visualize things like this, if you have this kind of picture, would be that you have a line representing all the numbers, where these are the plus numbers and these are the minus numbers, the negative numbers. So it's all 1, -1, +2, -2. That would mean that all these, so +1 would map to -1, plus 2 would map to minus 2. Minus 1 would map to plus 1. Minus 2 would map to plus 2. That's what, if we're, well, yeah, I wasn't clear on that. Well, what this is this is the operation multiply on all of x. Multiply, that's not very well written, is it? The operation of minus 1 times acting on all the numbers x. So it's like, so whereas this one, then it's all moving along a bit. This one, it's all stretching, and this one, it's reflecting like that. Okay. And I think this is a useful way of understanding what's going on when you multiply by minus 1. Thank you.